So this section is on comets, or sometimes long-haired comets. So mostly we're familiar with comets as the objects that occasionally are visible in the night sky, occasionally but rarely, and we can go out and see them. Here's a list of several that were prominent in history. The Great Comet of 1577, Tycho Brahe saw a comet, and it convinced him that the sun does orbit the Earth, and that was what led him on that journey to make all the measurements of the positions of the planets to see if he could prove Copernicus was wrong. Of course, he didn't, but he took really good data. There are other great comets in history. There's recent comets, like in the last few decades, Hyakutake, which is like the fifth one down on this list here, and Hale-Bopp. These were both visible around the time my children were born. I can remember holding up my daughter's head to look at Hale-Bopp in the night sky when she was about a year old. Swift-Tuttle. Halley's Comet is very famous, or Halley's Comet. And so we'll talk about these, but comets really comprise a class of objects that are the outer solar system equivalent of asteroids. Asteroids are rocky objects from the inner solar system. Comets are icy objects from the outer solar system. The image we get with tails is because they have been deflected or just pulled by the gravity of some passing object so that their course takes them into the inner solar system. And then when they go through this whole process that gives them a tail and everything else, and we'll talk about that in a minute. But mostly, comets are just icy objects that are minding their own business in the outer solar system with orbits way outside, say, the orbit of Neptune. And so we never see them or have anything to do with them. It's only when they get deflected and come in that they grow these long tails and become visible and are sometimes spectacular or sometimes spectacularly disappointing. So let me do a few pictures here. This is Halley's Comet. This was visible in 1986 when I was in graduate school, and they said it was going to be spectacular, and it was extremely disappointing. But we got to see it. It's famous because this guy, Edmund Halley, who lived right around the same time as Newton, he was maybe 10 or 15 years younger than Newton, and was one of the few people who really got along with Newton. He started looking at these comets as objects orbiting the sun. He was the first person who really did that, not just harbingers of doom or greatness or whatever. And he pulled out this particular one that seemed to be, there's in the records, every 76 years or so there was a comet that was seen, and it was in the records, and he decided it was the same thing, and so he predicted it was going to come back on a certain year, and it did. And so he became sort of famous for that. He did a bunch of other stuff in physics, but that's what he became famous for. And so the comet still comes by every 76 years. It was there in 86, and I think the next time it'll be is in like 2061 maybe, or something like that. So here's a picture of a comet that has come into the inner solar system. This is a drawing, obviously, but it lists all of the main features of a comet that you kind of want to know. And so let's just talk through this picture. So when the comet is in the outer solar system, all it is just an icy object, and that's what we call the nucleus. And this is 1 to 10 kilometers. That's 1 to 5 miles or something like that, 1 to 6 miles, in that range. That's the typical size of one of these objects. And it has two tails. One's called an ion tail or a gas tail, and the other one's called a dust tail. It turns out that gas and ions interact very strongly with the solar wind, and so the solar wind will push them away from the sun. Look at the direction to the sun in this picture. The sun is this way, and so the sun's blowing solar wind this way, and that the ions in that solar wind interact strongly with the gas and push that tail just straight back. It's like a wind, except it's much, 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 much thinner than the kind of winds we're used to here on Earth. The dust tail is dust that evaporates from the comet. I'll talk about this more in a second. And it doesn't interact with the solar wind very much, but the radiation pressure from the sunlight pushes on the tail and it pushes it back also. And so when you look at the tail of a comet, it'll often have two tails, not always, but often. They might be right inside each other or something, depending on where the comet is in its orbit. But there will be often these two tails sort of pointing away from the sun, generally speaking. Notice the direction of the comet here is to the down and to the left. So I've got a dust tail, an ion tail, and a nucleus. The ball surrounding the nucleus is called the coma, and that might be 100,000 to 1,000,000 miles in diameter. So you can tell that these tails and stuff, could be many millions of miles long, and that's why we can see them. Even though there isn't much material in there, they're lit up by the sun, and they're very large, and so they're often visible. And so these are the main features that you should know about a comet: the nucleus, the coma, which is around the nucleus, the dust tail, and then the gas tail or ion tail, and the approximate sizes of those things. So that's the direction the comet is going. Let me see if I can pull down another picture here. This is a particle of comet. Let me just see. This is just a mission. There's another picture of Halley's Comet. You can kind of see over here a gas, the dust tail and the ion tail. Sometimes they're slightly different colors. Let's do another picture here. So this is a little better picture, even though it only has kind of one tail that I can see there. You can kind of see that it's following some elliptical path. It's coming in near the sun and it's going out. Notice that generally speaking, the tail or tails are pointing away from the sun. Even though the comet's going to the right down here at the bottom, its tail is pointing away from the sun. There's no space wind that blows its hair back, and since it's vacuum out there, and so its interaction is mostly with the sun. What happens is, as it comes in notice the tail's getting bigger and bigger as it gets near the sun. As it comes into the inner solar system, gases evaporate from it. It's made mostly of ice, some dirt and ice. And as it gets warm in the inner solar system, all that stuff decides to turn back into gas, and that releases dust and gas. And that's what ends up producing the coma in the tail. It's all this evaporated material that comes from the comet. And so as the comet makes its laps around the sun, this stuff is constantly being evaporated, especially when it's in near the sun. And so we'll talk about that more later. Let me just put up another picture here. Here are a few nice pictures. So the top one, which comet is this? This is Hale-Bopp. I remember this one pretty well. Here's the gas tail and here's the dust tail. Here's the direction of the comet and here's the direction of the sun. This one I'm not familiar with. This is Comet Mikos, or Mikos maybe. And you can see the ion tail and the dust tail well illustrated here. So let's go back to the text for a minute. And so we've looked at some of the comets. Let's just scroll down here and we'll just go through some general features of comets. Comets are mostly icy objects with some rocks from the outer solar system, typically beyond Neptune's orbit. They're often called trans-Neptunian objects, and they have other names which I'll get to in a little bit. There are trillions of comets, but a few million asteroids. So think about that for a minute. A trillion is 1,000,000 times 1,000,000. So there's maybe 1,000,000 comets for every asteroid. So there's a whole lot more space. There's a whole lot more comets out there than asteroids. Most comets live in the outer solar system. Like I said, they're icy, rocky objects in two regions called the Kuiper Belt or the Oort cloud, and we'll talk about those more as we go. And so comets that enter the inner solar system typically start out, way out there past Neptune somewhere, maybe a mile or two across. As they enter the inner solar system, they warm up. As they do so, gases and dust evaporate from the nucleus. The gas and dust that surrounds the nucleus is called the coma. The coma can get 1,000,000 miles in diameter. So this stuff is just evaporating and kind of just hanging around that nucleus. Right? Pressure from sunlight and the solar wind, those are two different things, right? Sunlight is just the radiation, the light that's coming off the sun. The solar wind is all the ions that it's spewing out, these highly energetic nuclei that are ionized, that it's blowing out because it's producing so much energy. Those both interact with the comet. The gases around the comet strongly interact with the solar wind, and so that gas produces a tail that goes straight away from the sun. The dust interacts a little more strongly with the light from the sun, but it's much more massive than gas particles. Gas particles are kind of individual atoms or a couple of atoms in a molecule. Dust particles are dust particles, and so they're much heavier, they're much bigger, and so they don't get pushed as easily, but they get pushed a little bit by the sunlight. And so you get these curved tails that kind of point away from the sun. Remember that space is a vacuum, and so sometimes the tail is actually in front of the comet as it's going through its orbit if the sun is behind the comet. And so let's talk about some orbits here. So there's a region outside of Neptune called the Kuiper Belt. It was discovered by a guy named, or predicted by a guy named Gerhard Kuiper, who said, look, there's a lot of space out there in the plane of the ecliptic, in the plane of the planets, and it's probably got a lot of things that didn't form into planets out there. And he suggested that out to maybe 50 astronomical units, remember, Saturn is at 10, Uranus is at 20, Neptune is at 30, and so he expected there to be more large objects out there in the plane of the solar system, and sure enough they were. More than 1,000 Kuiper Belt objects have been discovered. They're probably hundreds of thousands larger than 50 miles across. It's another reason we kicked Pluto out of the club, because we expect that the farther out we go, we're going to find more and more Pluto-like objects, and of course we have. And so we have dwarf planets for that. The Oort cloud, so that's in the plane of the solar system. The Oort cloud was named after a Dutch astronomer named Jan Oort, who lived from 1900 to 1992. The Oort cloud is spherical, and it extends out to maybe 50,000 astronomical units, so 1,000 times farther. Recall that Neptune is, that should say 30 astronomical units. That's an honest mistake. The Oort cloud is spherical in shape. Recent comets Hyakutake and Hale-Bopp and Halley originated in the Oort cloud. There are probably trillions of comets in the Oort cloud. Again, way, way more than there are asteroids. The total mass of asteroids is about the mass of the moon. So all of that space that's filled up with asteroids just amounts to the moon. All that stuff between Mars and Jupiter. That's why we don't worry too much about sending a spacecraft through there and hitting something. If you took all of the asteroids, that would make something as big as Saturn, but once again, it's spread out over a much, 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 much larger space. I'll have a picture of that in a second. So let me just see if I can just bop over to that. Here we go. These are a couple of comets from up close, just icy, rocky-looking objects. This is one of them that's outgassing as it came into the sun. You can see that little region spewing there. As areas get warm, they heat up, and the gas can be pressurized and eject, and so you can get all this stuff just coming off it. You see over Saturn. Chiron orbits the sun every 50 years. There are some comets with orbits in the inner solar system, or at least inside the orbit of Neptune, and it just depends on what the fates had for that comet. Some of them get deflected in such a way that they get trapped in a small orbit, others in a bigger orbit. So here's a picture of sort of the whole thing, and you can look in here and sort of see there's the sun at the center, and Mercury, Venus, Earth, and Mars, and then there's a little gap for the asteroid belt, and then Jupiter, Saturn, Uranus, and Neptune, and that's out to maybe 20 or 30 astronomical units. You can see this is on a log scale, so this is in astronomical units, so it's 1 astronomical unit, 10, 100, 1,000, 10,000, or 100,000. So this is a weird scale. So here's the Kuiper Belt. It's out beyond the orbit of Neptune, and it's in the plane of the solar system, and there's some comets in there. But the Oort cloud extends well beyond that, and it's spherical in shape ultimately. And so those objects are no longer constrained to the plane of the solar system. There's stuff that didn't quite collapse in, excuse me, with the sun, when the sun was forming, and so they're icy, rocky objects that are way, way out there, mostly that just stay out there and mind their own business in their orbits. But occasionally one gets deflected in such a way that it gets sent into the inner solar system, and it gives us a spectacular show sometimes, or a disappointing show. So many short period comets, as I was just saying, had their orbits changed by coming too close to one of the planets like Jupiter or something like that. Centaurs are names of, if you remember, a centaur is a mythical half man, half horse animal, and there are some objects that are partly like an asteroid and partly like a comet, and you can imagine that those would exist because there's not a well-defined region separating comets and asteroids. The objects can form anywhere in there. And so sometimes we get something that's sort of in between those guys. Comet's atmosphere is its coma, so it's mostly water vapor or other hydrogen compounds. That stuff is what gets released because it comes into the inner solar system where it's warm. The Rosetta mission was just the first mission to put a lander on a comet. It was Comet 67P. The spacecraft was launched in 2004 and met with the comet in 2014, dropping a lander on it, which worked for a short time but lost power. And so we've already landed on a comet. We've done some interesting experiments collecting comet dust by flying through the tail of a comet and things like that. Comets typically come from the Kuiper Belt and the Oort cloud. Comets, like asteroids, are from the primordial solar system. So they formed when the solar system formed, and they're just out there, in both cases, asteroids and comets. And the ones from the Oort cloud are obviously the farthest away. They can have orbits of thousands or even 100,000 years. When they come in, just by following the shape of the orbit, astronomers can tell how long its period is. We have comets that have, an orbit out to Jupiter or something like that, that just have orbit on the order of tens of years, like Halley. But you can even get thousands of years from the Kuiper Belt. So a comet typically lasts a few hundred orbits, and that's about it. Maybe a few thousand, depending on how close to the sun its orbit takes it. An orbit that gets really close to the sun, that comet will get evaporated pretty quickly. And so over time, each time it makes a pass, each time Halley's comet makes a pass, it loses some dust and gas that get pushed away from it. They get evaporated by the sun, and they go into the coma, and they get pushed out into the tail, and they don't really get pulled back in, or most of it doesn't get pulled back in. And so eventually, there's no nucleus left. And what that means is that the comet kind of isn't there anymore, and all you have is a scattering of dust through the orbit of this comet that used to be. And that's what meteor showers are. Meteor showers are predictable. It's the Earth passing through the path of a dead comet. And so as we pass through the path of the comet, all these gas and dust particles that are still traveling along that orbit, they're just out there in space. There's nothing stopping them. So even though the nucleus is gone, all those particles from the coma and the tail are now sort of distributed all throughout that elliptical orbit. And as the Earth goes through, the atmosphere will get peppered by these tiny little particles of dust and gas. And as they burn up in our sky, we see shooting stars. So that's what meteor showers are.